So hi guys, welcome to TESPERT MBA Prep. So in this session, we will look into time, speed and distance. Very important concept for any MBA entrance exam. So this is the part 1 of the session. So whenever we hear about time, speed and distance, the first relation that comes to our mind is speed is equal to distance by time. So here when distance is constant, when d is constant, time is inversely proportional to speed. When speed is constant, what happens? Distance is directly proportional to time. When time is constant, then distance is directly proportional to speed. And after this, we will look into some example problems where we picked from previous year CAT questions. So don't skip this video if you are very much confident enough about this topic. Then you may skip this video, that's your wish. But if you are a beginner or if you want to clear your basics, then you shouldn't skip this topic. So the next thing is converting kilometer per hour into meter per second and vice versa. So how can we convert kilometer per hour into meter per second? Let's say we have 3 kilometer per hour. How to express this into meter per second? Well, you can just multiply with 5 by 18 to convert anything which is in kilometer per hour into meter per second. Whereas to convert meter per second into kilometer per hour, you can just multiply it by 18 by 5. Let's solve this simple example. If ratio of speeds of P, Q, R and S is 2:3:4:5, then the ratio of time taken by them to cover same distance will be. Alright. Here we know that speed is inversely proportional to time. So what is the ratio of speeds here? 2:3:4:5. So as speed is inversely proportional to time, we have to take the inverse ratios. 1:2 is to 1/3, 1/5. So take LCM, we'll get 60 here and this is 30. So the ratio of time taken by them to cover the same distance will be 30:20:15:12. So just this relation is important. So how can we express average speed? Forget about that harmonic mean, but what is how can we express average speed? Average speed is equal to the total distance by total time taken. So in this question, so find the approximate average speed when a person travels first 10 kilometers at 4 kilometer per hour and next 20 kilometers at 5 kilometer per hour and further 30 kilometers at 6 kilometer per hour. Okay, so here what is the total distance? So we are asked to find out the average speed. So average speed, we know the total distance by total time taken. So here what is the total distance? The 10 kilometers the first one, 20 is the second part and 30 kilometers the third one. So 10 plus 20 plus 30, that is 60 divided by total time. So total time for the first 10 kilometers is, we don't know the direct value, right? We don't know the value. So calculate time now. So time will be distance by speed. So distance in first case is 10 by speed is 4 kilometer per hour. Distance in second case is 20 kilometers by speed in second case is 5 kilometers. Distance in third case is 30 kilometers by speed is 6. So take LCM, we will get the final value as 5.2 kilometer per hour after taking LCM and solving it. So 5.2 kilometer per hour is the approximate average speed of the total journey. Let's move on to the next one. A person travels from P to Q at a speed of 40 km per hour and returns to P by increasing his speed by 50%. what is his average speed in kilometer per hour for the whole trip, right? So the person travels from P to Q at a speed of 40 kilometer per hour, right? And he returns to P by increasing his speed by 50%. So he increased his speed by 50%. What does this mean? So 40% plus 50% of 40%. So 40% plus 40 plus 50% of 40%, that is 20. So 60 kmph is the return speed. So we are asked to find out the average speed. Average speed we know the total distance here. So we don't know the value, so let it be x. From P to Q it's x, and then from Q to P it's one more time. So time is distance by speed. So distance by what is speed here? Speed in first case is 40 and speed in second case is 60. So after taking LCM, x and x get cancelled and we'll get 2 into 60 into 40 by 100. So we are left with 48 kmph. So option C is the right answer. So yes, distance is constant here. As we observe, we can also solve this by using one more method, which is 2ab by a plus b, this one, where a and b are the speeds of the person, right? So this is an harmonic progression, harmonic mean. So here 2 into what is the speed of the first one? In first case it's 40 and speed in second case is 60 by 40 plus 60, that is 100. So cancel it and you'll get 48 kmph. But I don't recommend this one, because if you know the concept and follow the standard method, it can be applied anywhere. Whatever the difficulty level of the problem, it can be applied anywhere. If you follow some shortcuts or if you follow some formulae that has a lot of conditions, it won't be fruitful, right? So understand the concept, try to solve it by either by traditional method or by standard method, right? So that you can use that in any exam, even if the questions are twisted, like the questions that appear in CAT or XAT, you can apply that standard method, right? Let's move on to something called product constancy. We already are aware of this concept. We already discussed in percentages, right? But we'll recall it once again. We recall it once again. So product constancy means if we take three entities A, B and C, right? Let's say if A is increased by some percentage, then in order to make this one, make C as constant, to remain constant, B must be definitely decreased, right? If A is increased, B must be decreased in order to make constant, right? In the same way, if A is decreased, B must be increased. But in what percent? What fraction it must be decreased? In what percent it must be decreased? That is what is known as product constancy. Here we have a table to remember everything in product constancy. We can easily calculate the values by remembering this table. Let's say A is increased by 1 by 4, right? 1 by 4 means 25%. So the percentage equivalent is 1 by 4. So if A is increased by 1 by 4, then how much percent must B be decreased so that C will be constant? So in order to find this, you just move one step towards right side. So if A is increased by 1 by 4, that means 25%, B must be decreased by 1/5, which is 20%. Let's say if A is decreased by 1/4 in a case, then how much must B be increased then you must move one step backwards. So B must be increased by 1/3. That is 30. It must be increased by 33.33% when we express that in percentage. So one step forward to know the to find decrease, and one step backward you must move to find increase. So these are all percentage equivalents. So 1 by 4 is 25%, 1 by 3 is 33.33%, right? 1 by 1 is 100%. So these are all the percentage equivalents. For instance, take this example. When A increases his speed from 40 km per hour to 50 km per hour, his time for the journey decreases by 4 hours. So how long does it take for him to complete his journey at 40 kilometers per hour? Of course, you can solve this by using the traditional method, but here we will apply the product constancy here. So speed increased from 40 to 50 km per hour. That means speed increased 1/4, right? 1/4 has been increased. This is speed. So what about time? So how much must time be reduced? See, in the number line I told you, right? If this is 1 by 4, then if you move one step forward, then you are trying to know the decrease value, right? So if 1 by 4th is increased, then what must be the decrease in value? 1 by 5th. So time must be decreased by 1/5. So 1/5 of time is equal to 4 hours, right? So his time for the journey decreases by 4 hours. So so the 1/5 of time is equal to 4 hours. So total time will be 4 into 5, that is 20 hours. So for me, the product constancy method is comfortable, so I use this. The traditional method, we can use this, but the answer doesn't change, everything doesn't change. We can easily calculate by using product constancy method, right? It's a standard method. So let's move on to one more example. A train met with an accident 180 kilometers from station A. It completed the remaining journey at 5/6 of its previous speed and reached 2 hours late at station B. Had the accident taken place 400 km further, it would have been only 1 hour late. So what's the speed of the train and what is the distance between A and B? So this is station A and this one is station B. So a train met with an accident 180 kilometers from station A. So 180 kilometers from station A. So it met with an accident somewhere here. Let's take this as yes. Okay. So this is 180 kilometers. So it met with an accident here. So had the accident taken place 400 kilometers further, let's say if the accident had taken place here, somewhere here, let's name this as S dash. So 400 kilometer further, so the distance from here to here is 400 kilometers, right? So if the accident had taken place, then it would have been only 1 hour delay. Understood? If the accident had taken place at S dash, then it would have been only 1 hour delay, but it met with an accident at S and it reached 2 hours late at station B. So it met with an accident at S and it reached 2 hours late at station B. So this will be 1 more hour delay. See, please understand here. If the train had met with an accident at S dash, then it would have been 1 hour delay. But in this case, the train met with an accident at S. It is 2 hours delay. That means from S to S dash it's 1 hour, and from S dash to B it's 1 more hour. So it is 2 hours. When you are thinking from the perspective of S, then don't consider S dash. So anyways, it's from S to B, it will be 2 hours delay. But when you are thinking from S dash perspective, then anyways it's 1 hour delay, right, from S dash to B. So if this is 1 hour and this is total distance is 4 kilometers, then this is 1 hour and this distance must also be 400 kilometers, right? So this is 400 kilometers and this is 400 kilometers. So our answer to the second question, that is what is the distance between A and B? A and B total distance is 400 plus 400 plus 180. This is 980 kilometers. Now let's move to the first one. What is the speed of the train? See here, it completed the remaining journey at 5/6 of its previous speed. So 5/6 means it's definitely decrease in speed. So 5/6 means 1/6 decrease. So if speed is decreased by 1/6, then how much should it be increased? Remember that number line. To find the value of increased, to find the increased value, you must move to the left side, right? So 1/6, one step towards the left, that is 1/5. So speed is decreased by 1/6 and time is increased by 1/5. So 1/5 of time is equal to 1 hour late, right? 1 hour late. So total time is 5 hours. So we know speed is total distance, that is 400 here, 400 in this case. So speed in this case is 400 by distance. So this will be equal to 80 km per hour. Hence the speed of the train is 80 km per hour. Relative speed. So what is meant by relative speed? Let's say you are here, you are at this point, right? You are moving at a speed of 10 km per hour. Here there is a tree, right? This is a tree and you are moving at a speed of 10 km per hour. So this is your reference point as of now. And if you consider second case where your friend is also moving now, along with you, your friend is also moving, but he is moving at a speed of 5 km per hour. Now if you compare yourself with your friend, then this is known as relative speed, because both the objects, both the bodies are in motion. No one is in rest, right? So relative speed, the term relative comes only if the bodies are in motion. They won't be in a state of rest. So when two bodies move in same direction, like in this case, right, then the speeds of both the bodies get subtracted. In this case 10 minus 5, that is 5 km per hour is the relative speed. So in this case both the bodies are in same direction, so speed of A minus speed of B is the relative speed. What happens when both the bodies are in opposite direction, when they are moving in opposite direction, then the speed of A gets added to speed of B to find out the relative speed. So when two bodies move in opposite direction, the relative speed or the effective speed between two bodies will be the sum of their respective speeds. Let's solve this question that appeared in CAT 2006. So this is related to relative speed. That's why we picked up. So A, B, C start from the same place and travel in the same direction at speeds of 30, 40 and 60 km per hour respectively. Now B starts 2 hours after A, and if B and C overtake A at the same instant, how many hours after A did C start? Alright, so this is A started from here, this is B, this is C. See, all three A, B and C start from the same place and travel in same direction. So A, B and C, they are starting at same places and their speeds are 30, 40 and 60 km per hour respectively. So A started now, B starts 2 hours after A. So A started and traveled for 2 hours. So in 2 hours, how much distance did A cover? Distance is speed into time, right? So what is speed of A? Speed of A is 30. For how many hours? For 2 hours. So distance covered by A in these 2 hours is 60 kilometers. Now after 2 hours, B started moving towards A, right? So B started. First, B must cover this distance that A covered. So in relative speed, please remember this, you can solve it in one more way, but how I solve is, we assume the slower body to be stationary. If we assume the slower body to be stationary, then the complexity of the problem definitely gets reduced. It will definitely get reduced. Let's see how. See, let me write it here. Whenever you are solving any problem related to relative speed, assume the slower body to be stationary and the time now becomes, time is equal to distance by speed. As you are assuming that one, that the stationary the slow body to be stationary, to nullify that, to nullify this one, this assumption, what should we do? We should take the relative speed in the denominator instead of speed. So we must consider relative speed instead of speed. This is just to nullify our assumption that the slower body is stationary. We'll come back to this while solving this problem. So here, if we assume A to be stationary, then how much time will B take to catch A? See, the distance is 60, right? The difference is 60. The total distance is 60. As I told you, in denominator, whenever we assume that the slow body is in stationary, we shouldn't take speed, we should take relative speed. So as A and B are moving along the same direction, we must subtract the speed. So what is speed of A? 30. Speed of B is 40. So the relative speed is 40 minus 30, that is 10. So answer is 6 hours. So A takes 6 hours to reach, B takes 6 hours to reach A. So B takes 6 hours to reach A, but in 6 hours, how much B travels? In 1 hour it travels 40 kilometers. So in 6 hours it is 240 kilometers. So B should have traveled 240 kilometers in 6 hours. So B somewhere meets A here at this point. Then what about C? So in the question it's given that B and C overtake A at the same instant, at the same time. So C must also definitely meet A at this point. But how much time does C take to meet, to move to that point? Again, take the relative speed here. Think as if B is stationary. Why? Because B is slower than C, right? So the slower object can be stationary. Assume like that. So here C takes how many hours? The distance is 240, right? So C takes 4 hours here. So it takes 4 hours. And how much does A take to arrive at this point? So the total distance A is traveling is 240 and the speed is 30. So A takes 8 hours to come to this point, and how many hours after A did C start? Okay, so how many hours after A did C start? So 8 minus 4, which is equal to 4 hours. So answer is option C. So a thief committed a burglary and started fleeing at 12 noon at a speed of 60 km per hour. He was then chased by a policeman, and the policeman started the chase 15 minutes after the thief had started, and at the speed of 65 km per hour. At what time did the policeman catch the thief? Alright, so here the policeman started 15 minutes after the thief, right? So if the policeman is here, he started at 12:15 p.m. By the time the policeman has started, the thief had already traveled 15 minutes. So the difference is 15 minutes. Let us assume the thief to be stationary, because the speed of thief is slower than speed of the police. So as this is a slow body, we can assume this one to be stationary. Now in 15 minutes, how much did the thief completed his journey? How much did the thief cover the distance? He covered 15 kilometers, because his speed is 60 km per hour. So that means for each and every minute he is traveling 1 kilometer. So 15 kilometers he covered already. So time is distance by speed, and distance here is 15 kilometers, and speed is, what's the relative speed? 65 minus 60, that is 5 kilometers. So 3 hours are required for the police from 12:15 p.m. to catch the thief. So 12:15 plus 3, that is equal to 3:15 p.m. We shall now look into the to and fro motion in time, speed and distance. So we have two cases. The first one is opposite direction, the second one is same direction. First we shall look into the opposite direction and how to calculate distance in opposite direction. Let's say the distance between 2 points P and Q. Let's say here it's P, here it's Q, and this distance is 900 meters. A is at P and B is at Q, at P and Q respectively. So speed of A is 50 meter per second and that of B is 40 meter per second, and A and B travel to and fro between P and Q. And what's the total distance covered by them before they are together for the first time? So what is the total distance covered by them? See, A starts from here and B starts from here. As the distance of A is more, as the speed of A is more than B, the distance covered by A should also be more than B. So B and A meet somewhere here. Okay. So A traveled some distance and B traveled covered the remaining part. So the total distance that they covered for the first time is, before they are together for the first time, is 900 meters. What about second time? Now what happens is, let me change the color now for better visibility. So P initially, say after meeting, P again moves from here to here, and again it takes the U-turn, and in the meanwhile B resumes his journey from here and then turns again, and A travels from here to here. See, second time they are meeting here, and now they travel for this one 900, this is 900, total 1800 meters, and from first to second it is 900 plus 1800, that is 900 for the first time and 1800 for the second time. What about third one? Of course this is nth one, but for better understanding, what about the third time? How much A and B covered before they are together for the third time? That is one more 1800, right? 900 for the first time, 1800 for the second time, and especially for third time it's one more 1800. What about nth time? Nth time it's 900 meters initially plus n minus 1 into 1800 meters. So if it were 100th time, then the value must be 900 plus 100 minus 1, that is 99 into 1800 meters in this case. So what about time calculation? How can we calculate time? So here, take before they are together for the first time, second time and nth time. So this is P and Q. A is here and B is here. A traveled from here, A started from here and B started from here, and they both met somewhere here, right? So the time is equal to total distance by total speed. Here total distance is 900 meters by total speed we know, that is 90 meter per second. So this is relative speed, 50 plus 40. This is not relative speed, this is total speed. Don't confuse here, because here of course relative speed is also 90. The value of relative speed in this case is also 90, because the bodies are moving in opposite direction, so we must add them. But here we are not considering, we shouldn't consider relative speed, we must consider total speed. This is total distance in the numerator, total speed in the denominator, and total time taken is 10 seconds, right? And what about second case? Second case, it is 1800, right? We calculated in the previous slide. So 1800 by the total speed. Speed is 90 meter per second, so this will be equal to 20 seconds. And what about nth time? Nth time is 10 seconds for the first time and n minus 1 into 20 seconds for the remaining. What about time ratio? How can we calculate the ratio of time? This is P, this is Q, B is here and A is here. We know the distance is constant here. Distance is constant. When distance is constant, we also know that speed of A by speed of B is equal to time taken by B by time taken by A, because it is inversely proportional. Speed is inversely proportional to time. What about speed of A? Speed of A is 50 by speed of B is 40 meter per second, and time taken by B by time taken by A. So this ratio is equal to 5 by 4. So the time taken by A to cover from P to Q by time taken by B to cover from Q to P will be same ratio, 4 by 5, right? Because A corresponds to 4 and B to 5. Here also A to 4 and B to 5, right? So the ratio is 4:5. This is the time ratio. Now the second case, that is same direction and the distance calculation. So distance between 2 points is P and Q. This is P, this is Q, and the length is 900 meters. Now A and B start from P, because this is same direction, right? Now A and B start from P. As the speed of A is greater than that of B, A travels here and again it turns back. Now B in the meanwhile comes here and they meet somewhere here. So the distance covered before they meet for the first time is, this is 900, this is one more 900, this is 1800 meters. I think you must have observed the difference between the same direction distance calculation and opposite direction distance calculation. In opposite direction distance calculation, it was 900 meters initially, that too for the first time, and in this case this is 1800 meters, whereas in second time before they meet, the total distance covered by them will be one more 1800, so 1800 into 2. For the nth time it is n into 1800, right, meters. So this is a concept. Now we will look into this problem. See why I am explaining the standard concepts is you can apply this in any exam. Even though the questions are twisted, slightly twisted, like in CAT and in SAT, even in IIFT. Of course, in IIFT, it's like a calculation game where a lot of calculations are involved rather than logic. But in CAT and SAT, unless you have sound knowledge on your concepts, you cannot answer the paper comfortably. That's why understanding the concept must be your first priority rather than giving mocks or rather than practicing questions. After that you can practice. First clear the concepts first. Okay. So excluding stoppages, the speed of a bus is 54 km per hour, and including stoppages it is 45 km per hour. For how many minutes does this bus stop per hour? It's a frequently asked question. We can solve this by using traditional method, but it is not advisable because this is a standard concept, standard method. So we can use this shortcut. I will write it down here. So difference of speeds by excluding stoppage speed into 60. So this excluding stoppage speed is also known as the higher speed, the speed which is higher, right? Higher speed. So difference in speeds here, what is the difference? 54 and 45, 9. And the excluding stoppage speed, that is excluding stoppage, 54 kmph, right? 54 into 60, calculate this, you'll get 10 minutes. The answer is 10 minutes. Very simple. No traditional approach is required for this standard problem. Whenever you find stoppage, excluding stoppage, including stoppage, you can definitely apply this directly. In a flight of 600 kilometers, an aircraft was slowed down due to bad weather. Its average speed for the trip was reduced by 200 km per hour and the time of flight increased by 30 minutes. The duration of the flight is, let's say here the duration of the flight to be x hours. Then the speed was reduced by 200 kilometers. Speed was reduced by 200 kilometers. So speed will be equal to distance, that is 600 by total time, that is x hours, minus 600 by after slowing down. So 600 is the total distance by, so it is increased by 30 minutes, right? So x plus 30 minutes, so convert that into hours, 1 by 2. Now take LCM and we'll arrive at the quadratic equation 2x square plus x minus 3 is equal to 0, and solve this. 2x, I think this should be plus 3, and x minus 1, this will be equal to 0, and x will be 1r, because we won't consider the negative value, right? X is minus 3 by 2, that's negative, so we shouldn't consider that. So x will be of 1 hour, the duration of the flight will be 1 hour. So this is the part 1 of time, speed and distance. In case you haven't yet joined our Telegram group, join us. And thank you all the subscribers who have already subscribed, and still if you haven't subscribed our channel yet, subscribe it to never miss the updates from our end. Thank you very much for watching this video. Hope this is definitely helpful, and practice questions now. Thank you very much.